In this lecture we will be studying about Arden's theorem. So this Arden's theorem is important when you deal with regular expressions, and it states that if P and Q are two regular expressions over sigma, and if P does not contain epsilon, then the following equation in R given by R equal to Q plus RP has a unique solution, that is R equal to QP star. So this Arden's theorem is telling us that if you have two regular expressions P and Q over this sigma, and if P does not contain epsilon, then this equation R equal to Q plus RP, it has a unique solution that is given by R equal to QP star. So that means that whenever you get an equation of this form, R equal to Q plus RP, you can directly replace it with R equal to QP star, because this is a solution to that, as stated by the Arden's theorem. So in this lecture what we'll do is we will prove this. So first we'll prove that R equal to QP star is a solution to this equation, and after proving that we will also prove that this is a unique solution, means this is the only solution to this equation. Okay, so let's get started. So first we'll take this equation R equal to Q plus RP. So this is the first equation that we have, that is this one. So let me call it equation number 1, and we are going to prove that this is a solution to that. So what I'll do is I will replace R with QP star. So here equal to Q plus this R, I will replace it with QP star. So instead of this R I will write QP star, and then I have P over here. Okay, so now we get this, and from here I see that I can take out Q as common. So if you take out Q as common, what we get is here instead of this Q we'll get epsilon plus, and Q is taken out, so P star P. So this is what we get. Now if you remember in the previous lecture when we studied about identities, we already studied that epsilon plus R star R, where R is any regular expression, is equal to R star. So this was one of the identities in the previous lecture. You can refer it if you have not watched. So here in the same way we see that we have epsilon plus P star P. So this whole thing can be written as P star. So Q P star. So now we see that when we replace R with QP star, we are getting QP star over here. So we have just proved that R equal to QP star is a solution to this equation that we got here. So we have proved the first part of Arden's theorem. Okay, now let's prove the second part. And what is the second part? The second part, we have to prove that this is a unique solution, means this is the only solution to this equation. So in order to do that, let me take this equation again, R equal to Q plus RP, and now in this equation let me replace R with this itself, that is Q plus RP. So Q plus, instead of R I'll put the whole thing, Q plus RP, Q plus RP, and this P will come over here, this is P. Okay, and now let us continue. So how can I write this? Q plus, if I take this P inside, this becomes QP plus RP square. Okay, now we have an R again over here, so let me replace this R also with Q plus RP. So Q plus QP plus this R, I will write it as Q plus RP, and this P square comes over here. So this will be written as Q plus QP plus, I'll take this P square inside, so this becomes QP square plus RP cube. Okay, so if you continue this n number of times, you will get Q plus QP plus qp square plus it goes on up to qp to the power n plus rp to the power n plus 1. Now why did I do this? If you observe it here, you see that when the second last term is a square, then the last term is a cube. That means 2 plus 1, 3. So in the same way, if the second last term is n, then the last term, this rp term, will be n plus 1. So this is how we get this. Okay, now we see that we still have an r here, and this r, let me replace it with r equal to qp star. Let me replace it with this term in this equation now. So I get q plus qp plus qp square plus goes on up to qpn plus, instead of r I will put qp star and pn plus 1. Okay, from here now if we take out q common, let me take out q common. Now what do we get? Here we get epsilon plus p square plus goes on pn plus p star pn plus 1. Okay, if you observe this, what is this? This is epsilon plus p square plus pn plus pn plus 1. This whole term, it represents the closure of p. So you can write this as q, and this can be represented as the closure of p, that is p star. So this is p star, this whole term. So again we get at the end r is equal to qp star. So we have proved that this is the only solution, that is the unique solution for our equation that was given. So this is how we prove the Arden's theorem. So once we prove this Arden's theorem, we can write r equal to qp star whenever you get this kind of a equation. So I hope that was clear to you. Thank you for watching and see you in the next one.